this.
The longitudinal bar, Y20, why is it going from beginning to the end? It is going because stresses are generated inside the concrete. And the moment the stresses are generated, this bar takes them from one point to the other. So it can take it up to 1,000 kilometers, provided there is no break. So where there is break, like in bridges, we have to do something. We have to dig at the head of the bridge a beam, and the design of the beam I've sent to all the contractors, so that you will terminate this longitudinal bar. You terminate it there. What does it do? It restrains the movement of the stress, so they're buried. It's like what is called cathodic protection. When you have a pipeline and it's passing over this high tension, there is cathode and anode movement. So you have to do something to take ions and bury them, and now ended inside there. So this is why it's called continuous reinforced concrete pavement. Now, where you place this iron is very important. You can see it is placed at the neutral axis. But in engineering, we are told that if you are doing drainage and you place your reinforcement at the neutral axis, it's doing no work. You have to place the reinforcement where it can counter the lateral both water pressure and earth pressure, as the case may be. So, but this one, the stress occurs at this neutral axis, and so it takes the stress off continuously. And that's why you don't have any the core expansion joint, you don't have it, because this continuous reinforcement is taking care of that. But if you are using a BRC mesh, about 30% of the depth of the concrete, if you are using 230% of it, it's cut, because you are using BRC mesh. But you must do everything possible to lay the BRC to be also at the neutral axis, so as to counter the forces. Now, the mixture of the concrete is also very important. If the concrete has a lot of water, then you are wasting your time, because what it does, if it has a lot of water, is that the stones will be separated, the sand will be separated, the cement will be separated. So it's no longer, a concrete. A concrete is defined by the aggregation of the aggregates, the chippings, the sand, and the cement. When you have water, two things happen. It separates the aggregates, and so it's no longer strong. So some places you have only chippings, other places you have just very soft. Then number two, in volume, if you have a lot of water in a concrete, when it evaporates, it now leaves a vacuum, and that's why you have cracks. So the water cement ratio, is maintained in most cases about 0.4, but it depends on the mixture. So this is very important, and I want our engineers to take absolute care of these details. If you behave well with concrete, it will behave well with you. But if you get it wrongly when you are mixing it, then you have a problem with it. Now, finally, I spoke extensively about how to prepare our roadways, that no place should anybody remove our existing asphalt again, or you are using concrete. You must use that milling to mix with the stone base and lay across 11.55. This is very important, because that asphalt is gummy. Okay? So when it mixes with the stone base and then cement, it gives us an impervious layer that concrete will love to, sit on. This is very important. So the expansion of the shoulders is very important. For those who are doing debating when we were in secondary school, you say, with this, I want to prove to you that concrete pavement has come to stay.